Hello everyone, I am Alok Kumar and I welcome you today to this first lecture in the 3 lecture series on 3D geometry. So let me now quickly share my screen with you all and start the lecture. Okay, so there we go. So first of all, I will start a very important concept, and that is the whole foundation of, say, your 3D geometry. So we define something called direction ratios and also direction cosines. So if you say direction ratios, then it's like this: that given x, y, and g, this is the usual coordinate axis. So x, y, g are the 3D geometry axis, and suppose there is some line that you call OP. This is O and this is P. Then this OP makes an angle alpha with the positive direction of x-axis and angle beta with the positive direction of y-axis and an angle gamma with the positive direction of g-axis. So this is gamma. Now these numbers alpha, beta, and gamma, they are called direction angles. They are called, in some sense, direction angles of line OP, or sometimes you may say directed line OP. So in vector, it makes more sense to talk of directed line. In 3D geometry, we may not care much about this distinction. Now, the moment you have defined direction angles of line OP, then 3 numbers denoted by L. So L is cos alpha, M is cos beta, and N is cos gamma. They are called the direction cosines of the line OP. So in some sense, they are called the direction cosines of line OP, means they, of course, give you the direction in the space in which the line is oriented. In fact, if you talk of direction ratios, or in short, we call them DRs, and in the same vein, we can say direction cosines as DCs. So direction cosines of a line are the numbers. They are the numbers A, B, and C, denoted like this, such that these are proportional to the direction cosines. That is, already we have seen, that is L cos, that is L, M, and N, and that is given by cos alpha, cos beta, cos gamma. So in fact, you have got the direction ratios and direction cosines. Now, if ABC is direction ratio, of course, you understand that I can also take it to be negative A, negative B, negative C, because as such, you are doing 3D geometry, not the vectors, so that direction does not matter. Once you agree to this concept, then we have got this derivation, that L square plus M square plus N square, that equals 1. That's just a statement of that line OP. Line OP square, you can write in terms of sum of 3 squares, and that, of course, will give you this relation. So that is L square plus M square plus N square equals 1. This is a fundamental relation that we always use. Now, next one, that if there are points P and Q, and I write coordinate at x1, y1, g1, and x2, y2, g2, they are the 2 points in the 3D plane, in 3D space. So that is PQ. And if I join P and Q, then I say the direction ratios of the line PQ. Now they are given by x2 minus x1, y2 minus y1, and g2 minus g1. That is your you are just you're subtracting the coordinates of P from Q, or the other one also you can do. And these three numbers will define the direction ratios of the line. If you want direction cosines of the line, DCs of the line, then of course we can write x2 minus x1 and over PQ, and y2 minus y1 over PQ, and g2 minus g1 over PQ. And we can write like this enclosed with these arrows, because that will tell you that these are indeed, if you if you square and sum it, so sum of these squares, so this is like, it will be 1. That was, we started out with, that L square plus M square plus N square equals 1. In fact, once you have defined this, then we can also define the angle between lines. The angle between lines. And so we say that let's have L1, M1, N1 as the line L1 direction cosines, and L2 line has L2, M2, N2. So these two lines have these direction cosines. Then the angle between them, so the angle between L1 and L2, that is theta, suppose, is given by, so that is given by cos of theta is L1 L2 plus M1 M2 plus N1 N2. Those who have done vectors, they can quickly relate that this is the way we define dot product. And then the famous formula that A dot B is modulus A times modulus of B times cos of theta. And here modulus of A is L1 squared plus M1 squared plus N1 squared, that's 1. And same for modulus of B. If instead you are given, or you do not know that numbers A1, B1, C1 or direction ratio or cosine, so L1, L2, if I give general A2, B2, C2, if they are DRs, then the same angle cos theta will be now given by A1, A2 plus B1, B2 plus C1, C2 upon a square root of A1 square plus B1 square plus C1 square, n times the square root of A2 square plus B2 square plus C2 square. They are in fact modulus of these two, or again modulus of the vectors that we spoke about, that cos theta is A dot B over modulus A times modulus B. One formula that is often neglected is this one, that sine theta is given by, suppose in terms of, we write L1 M1 N1, L2 M2 N2, then sine theta I can write as L1 M2 minus L2 M1 whole square plus M1 N2 minus M2 N1 whole square, and plus N1 L2 minus N2 L1 whole square. To help you remember, I'll just draw here L1 M1 N2 and L2 M2 N2. So first row is L1 M1 N1, second is L2 M2 N2. You always go forward, and so first term you will write that L1 M2 minus this one, L1 M2 minus L2 M1. Then we can go to M1 N2 minus M2 N1, and then we can come with L1 N1 L2 N2. So N1 L2 minus L2 N1. So these all things we do even in cross multiplication. So this might seem very familiar to you. So just get it right. So sine theta is this one. And if you are worrying that how this comes up with these kind of things, there is a beautiful identity called Lagrange's identity, Lagrange. So Lagrange's identity, this identity means that we are saying that a squared, b squared, c squared times x squared, y squared, z squared. So this is sum of three squares, and this is sum of three squares. This is product of two numbers which are sum of three squares. And I can write it as ax plus by plus cg whole square plus ax plus, I can write ay minus bx. So this is this one. So it is going the same thing. So I can write abc and xyg. So I can write ay minus bx whole square plus ag minus cx whole squared and plus bz minus cy whole squared. So I'm again going the same fashion. A, b, x, y first this way, then a, c, x, g, like this, and finally BCYG. So we have formed these things. You can verify this is true once you get to this one and select ABC as L1 squared, M1 squared, N1 squared, and times L2 squared plus M2 squared plus N2 squared. You will get here L1 L2 plus M1 M2 plus N1 N2 whole square. And those three numbers which we wrote just above this line, that was L1 M2 minus L2 M1 whole square plus, I wrote in a different order, so M1 N2 minus M2 N1 whole square, and plus it was N1 L2 N1 L2 minus N2 L1 whole squared. Now because this is 1 and this also is 1 and this number is cos of theta, so you're getting 1 equal to cos square theta and plus this sum of 3 squares, this one, and so you are getting sine square theta is sum of these 3 squares, and this is precisely your this expression, that sine square theta, if you square root sine theta, is this one. So this also is helpful many a times when you do a problem, so just keep it in mind. Next, let me illustrate this simple concept by some problem. So I take up a classic problem. So maybe I will change the color a bit. And so this is a really classic problem which people have find instructive. So this classic problem I can tell and try to make a good diagram. So it says that a line, so a line makes angles alpha, beta, gamma, and delta with the diagonals of a cube. So there is a line that makes equal angle with the diagonals of a cube. And then you are asked to prove that sine square alpha plus sine square beta plus sine square gamma plus sine square delta, that equals 8/3. That equals 8/3. So this is what you have to prove, this one, 8/3. So let me make a good diagram that will be helpful to you even later. So first of all, what I'll do, that once I draw this kind of a cube, then I can quadratize the cube. So let me draw the cube in a beautiful way, let's say. So now this is your x-axis, this is your y, and this is your g. Let me level the cube first. So this is O, and let's write this as A, and this is your naturally B, and this is C. And this O is of course origin, so that is O is 0, 0, 0. Now I follow a different labeling. So this A is of course 1, 0, 0, I will write. B is 0, 1, 0, and C is 0, 0, 1. So you have got O, A, B, C, and this is 1, 0, 0, 0, 1, 0, and 0, 0, 1. So B corresponds to the middle one, A corresponds to the first one, and C corresponds to the third one. So it looks quite symmetric. And as it has got 4 more vertices, so the vertex opposite to O, I will level at O prime. The vertex opposite to A, let's level A prime. The vertex opposite to B, let me level B prime. And the vertex opposite to C, I will level C prime. So our other 4 vertices are O prime, A prime, B prime, C prime. Now O prime, you find O prime. O prime is like here. So you have got O prime coordinate. If you write, you will get 1, 1, 1. A prime, let me tell you A prime. So A prime will be 0, 1, 1. B prime, if you go to B prime will be 1, 0, 1. And if you come to C prime, it will be 1, 1, 0. Just note this beautiful symmetry, that if you want to change to O prime, then change all the zeros to 1 and ones to zeros. Similarly, from A to A prime, it means that from some vertex to the opposite vertex B prime, interchange 0 and 1. Wherever 0 is there, put 1. Wherever 1 is there, put 0. This gives a good way to coordinatize the cube And in many of the problems, you will find this is really effective, that all we do on problems about cube, that we start labeling the cube and we write these coordinates, which are quite easy to write even without this one, the way we have done scientifically. And then we are ready for many more problems. So this is my first good step, that I have done this. Now, the given line L has got, say, it has got LMN as some kind of thing. So let's say that LMN are the direction, LMN are the direction cosines. So let me say the direction cosines of the line. And with all the diagonals that make equal angle alpha, that makes angle alpha, beta, gamma, and delta, that's given. So let's write the direction cosines of, or direction ratios of, the diagonals. So we have got 4 diagonals: OO prime, AA prime, BB prime, and CC prime. Once again, we are reaping the advantage of having written in a good manner all the vertices. Had we written A, B, C, D, E, F, G, H, you remember, you would have a tough time finding, or we'd have, of course, to look at it. It's now almost automatic. I know O with O prime, A prime, B, B prime, C, C prime. So all 0 changes to 1, and every 1 changes to 0. That's the way to flip or switch from O to O prime and back O prime to O. And same holds for other vertices of opposite thing. Now, O prime has got direction ratios as, just subtract coordinates of O from O prime. So I'll get 1, 1, and 1. I write in closing brackets like this. A prime, if I write, I'll get negative of A, and then 1, and then 1. Similarly, BB prime, if I get, I will write 1 and negative of 1, and then 1. And if I write CC prime, then again I will get 1, and then 1, and then negative of 1. So these 3 are all positives, and there is one negative coming, negative near. Quite beautiful symmetry. A corresponds to this one, B corresponds to this, and C corresponds to this. So we got a good manner: O prime, BB prime, A prime, and CC prime, all direction ratios. And line L, already we know that line L has got dr as L, M, and N. So line L has got dr L, M, and N. And the angle between line L and, say, O prime, so angle between line L and O prime is given to be alpha. And so cos of alpha is, now apply the result, cos of alpha is L plus M plus N, and upon square root of 1 squared plus 1 squared plus 1 squared, and a square root of course L squared, M squared, N squared. But that's of course 1, so it's just L plus M plus N over root 3. Similarly, if I get L and A prime, then angle is beta, and cos beta equals, so negative of L plus M plus N, and over square root of 3, that's again same thing, then again gamma and delta. So cos gamma is, this negative will keep moving one step, so this is L minus M plus N over root 3, and cos delta is L plus M minus N over root 3. That's how mathematicians test similarly, that once you get to this stage, after this you get to this stage, you can say that, wow, just keep moving negative 1 step ahead till the time you reach the end. That's all. And so we could have written sigma cos square alpha, which was in full cos square alpha plus cos square beta plus cos square gamma plus cos square delta, and that equals 1/3 of, and so you have got sum of 4 squares, so that's L plus M plus N whole square, then negative L plus M plus N whole square, then L minus M plus N whole square, and then L plus M minus N whole square. So it seems that you are getting quite a mouthful, like it's like 1/3 of L plus M plus N whole square plus negative of L plus M plus N whole square plus L minus M plus N whole square plus L plus M minus N whole square. Oh my God, don't despair. This is quite easy. Let's use symmetry. So 1/3 is gone, and I won't expand. I would just use a very powerful identity, which I write as a background material, that we'll use that x squared plus y squared twice, that equals x plus y whole square, plus x minus y whole squared. This directly will use, that's good one to use always. And its cousin is 4xy is x plus y whole square minus x minus y whole squared. The more grip you have on these little gems, you will be at ease in any paper or an exam, and you can do it very quickly. So this I will think that, okay, this is m plus n, and so m plus n plus l and m plus n minus l. So I can write 2 times m plus n whole square. So let me make a bracket, n plus l square. Similarly here, I will look at it as, say, L minus m minus n, and this is L plus m minus n. So let's put a bar to show it. So it's like I got my x and y. So x minus y whole square plus x plus y whole square. So it's again twice of L squared and plus m minus n whole squared. That's good. So 1/3 of, you get 2 and 2l squared, so 4l squared already is out, and again 2, and you club them, m plus n squared and plus m minus n whole squared, and close the bracket, and 1/3 of 4l squared and plus, again apply third time. We applied this result first time here, second time, and then third time. So this is again 2 times, and this is 2 times m squared plus n squared, and that brings us close to it. So 1/3 of the 4 comes out, l squared plus m squared plus 1 squared. Beautiful. And this is because given to be 1, so this is 4/3. And so we have determined sigma cos square alpha, and then sine square alpha plus sine square beta plus sine square gamma plus sine square delta. That will be 4 minus this sigma cos square alpha. And so we get our first result, that 4 minus 4/3, and that equals 8/3. So we are good. We get our answer 8/3. Notice how we simplified things. This example tells you not much more about any tough things, but it tells you how to organize your work, how to be systematic, and how exactly not to be afraid of calculations. Here, cross terms did not matter. All cross terms got cancelled, just like they're arranged, as happens in maths. But you did not have to expand that. You just cleverly used x plus y whole square plus x minus y whole square is 2 times x squared plus y squared 3 times to get this beautiful result. Okay, so let me change a color one more time and go on to the next problem. So we can again do some more problems on direction, cosines, and ratio. So this question says that let L1, M1, N1. So let L1, M1, N1 and L2, M2, N2, and again L3, M3, N3. So these numbers are the direction cosines. So they are the direction cosines of three lines which are mutually perpendicular. Means these lines are mutually perpendicular. And then you are supposed to find out that there is a line L, and that makes equal angles with each of these lines. Then find the direction cosines of that line L. So given 3 lines with direction cosines L1, M1, N1 and L2, M2, N2 and L3, N3, N3, and given that these lines are mutually perpendicular, and there is a line L that makes equal angles with each of these lines, and you want to find the direction cosines of that line L. So let me start by naming these lines as L1, L2, and L3, normal nomenclature, L1, L2, L3. And then I will say that geometrically, I will try to look at situation. So suppose you have got the point O, and these 3 lines are like this, that this is OA, OB, and say OC. So if I form this kind of triangle, this triangle, this is OA, OB, OC, I take line equal, I take the lengths equal, say 1, 1, 1. So say each OA, OB, OC is 1. O is of course the good old origin. Now, so if direction cosine of OA is L1, M1, N1, then my question is, what are the coordinates of A? It turns out that if OA has got direction cosines as L1, M1, N1, then the coordinates of A themselves are L1, M1, N1, comma L1, M1, N1. Because if you write OA squared, then OA squared is L1 squared plus M1 squared plus N1 squared, that's 1. It means that you have got this one. Similarly, B coordinate is L2, M2, and N2, and coordinates of C, L3, M3, and N3. This is the first most important thing. Even there are many points whose coordinates are 1, but then mind you, this OA is something like along positive axis something. So we are getting our directed line segment. So we can say L1, M1, N1. Similarly, L2, M2, N2, and similarly L3, M3, N3. So once this is done, now we can think this way, that OA, OB is there. An angle between OA and OB, this angle, is same as between OB and OC, and same between OA and OC, which we cannot show. It's 3D, so it's something like this. Now, so this like OA, OC, so this kind of angle. So all angles are equal. It means that I can show it here that there was some triangle OAB. This is AB. There was something like OB and C. So that was like this. And there was something like O, A, and C. That was like this. Mind you, these all triangles are not in the same plane. We are just drawing the OAB triangle, then OBC and OCA, to emphasize that, okay, these lines, or these are equal lengths, these are equal lengths, these are equal lengths, and every angle, each angle of this angle, all are same. It means AB equals BC equals CA. It means triangle ABC is equilateral. We got our first good observation that this triangle is equilateral. Let me repeat that what we got is that OAB are equal. So OAOB is equal, they're both equal, and the angle between OA and OB, that is AOB, equals AOC equals BOC. And so these three triangles, in fact, they are congruent, and so we are getting that AB equals BC equal to CA, and so triangle is equilateral. Once that is done, equilateral triangle, then if you join the centroid, if you join the centroid of triangle ABC with O, that is Z, then I claim that this OG only, this OG is the line, OG is the line we are looking for. So OG is the line we are looking for, means this is the line that makes equal angles with OA, OB, and OC. Sounds good, because you have got something like OA, OB, OC, and there is a line in between here, which I can show by different colors, say green. And so there is a line something like here. So, and this line exactly goes to the centroid of triangle A, B, and C, which I can draw by a different color. And so we have got some triangles. So we have got this kind of triangles, A, B, and C. And so we can say that, okay, this is little ahead. So it goes through the centroid. So if this we take, then we already know A is L1, M1, N1. We know B also, and we know C also, that is L2, M2, N2. So coordinates of G becomes L1 plus L2 plus L3 over 3, M1 plus M2 plus M3 over 3, and N1 plus N2 plus N3 over 3. So that's the coordinates of G. And so direction ratios of OG I can write as L1 plus L2 plus L3 over 3, M1 plus M2 plus M3 over 3, and N1 plus N2 plus N3 over 3. Because it does not matter these three, because all direction ratios are proportional to each other. So this is also equivalent to saying that this is L1 plus L2 plus L3. m1 plus m2 plus m3, and n1 plus n2 plus n3. So these are my A, B, and C. So these are my A, B, and C sort of. So these are direction ratios of the line that I wanted, the line that makes equal angles with each of the given lines. And once that is done, I need to find its direction cosines. So I need to find a square plus b square plus c square, and that becomes L1 plus L2 plus L3 whole square plus M1 plus M2 plus N3 whole square plus N1 plus N2 plus N3 whole square. Now if you expand, they quickly cancel out main terms. L1 square plus L2 square plus L3 square plus twice L1 L2 plus twice L2 L3 and plus twice L3 L1. And then let me write one more term, m1 square plus m2 square plus m3 square plus 2 m1 m2 plus m2 m3 plus m3 m1 and n1 square plus n2 square plus n3 square plus 2 times n1 n2 plus 2 n2 n3 plus 2 n3 n1. If that is done and you add them up vertically, so when you add them up, you are getting this equal to, you have to add all these numbers. This is plus, so this we can write like that. So this is your thing, and this equals, so for the example, this gives you L1 square plus M1 square plus N1 square and two similar terms, sum of three squares. And this one, they give you twice of L1 L2 plus M1 M2 plus N1 N2 and twice two similar terms. Now because lines are perpendicular and they are L1 M1 N1 direction cosines, so these numbers become 1 each, 1 1 1, and they all go to 0 0 and 0. So this is 0, and so you are getting 3 here. So a square plus b square plus c square equals 3, and so you can say that the direction cosines of the line, they are given by L1 plus L2 plus L3 over root 3, M1 plus M2 plus M3 over root 3, and N1 plus N2 plus N3 over root 3. So that's my final answer. Okay. Let us change track and then do something that often get asked in exam. So you are given that find the angle between the lines whose direction cosines, whose DCs are given by L plus M plus N equal to 0 and twice Mn plus 3 times NL minus 5 times Lm equal to 0. Means you are given lines, you are said that, okay, that there are two lines whose direction cosines DCs are given by this relation, L plus M plus N is 0 and 2Mn plus 3NL minus 5Lm is 0. And you want to find angle between these lines. Sometimes they also ask you to find the lines themselves in more than one choice correct questions, or otherwise you can always be asked this kind of thing. So this has got a good method. So what we do is we eliminate first of all one variable, say anything out of them L, M, and N. So let's suppose that, let me eliminate N. So let me eliminate N between the two equations. So if that is the case, I can eliminate N between these equations, and so I can write using first one, N equals negative of L plus M. I plug this N here in the equation, but first I rearrange 2Mn plus 3NL minus 5Lm is 0 as I take N common. This is 2M plus 3L minus 5Lm equals 0. And this N is nothing but negative of L plus M from first one, and 2M plus 3L n minus 5lm equals 0. So I can write this as 3l square expanding, 3l squared, and 3lm plus 2lm, that is 5lm, and plus 2m squared minus 5lm equals 0. And if that is the case, I can further simplify it, writing minus 3l squared and minus 10lm minus 2m squared equals 0. Change the sign to end up with 3l squared plus 10lm plus 2m squared is 0. I can divide by m because it is not always 0. So this is L over m whole square 3 times plus 10 times L over m plus 2 equal to 0. Now comes the observation that suppose L1, L2, L1, M1, N1, suppose L1, M1, N1, so let's say L1, M1, N1, and L2, M2, N2 are the direction cosines of the two lines which have got this relation. Then this L by M will have two values, that is L1 over M1 and times L2 over M2. So product of these two values is C over A from the quadratic equation. So that we can write as 2 over 3. So that's equation 1, 2 over 3. I still need to do something more. So this time I will eliminate M. So this time same thing we'll do, we'll eliminate M. So this time I can write M equal to minus of L plus N. And the equation given was, it was NL 2Mn plus 3NL minus 5Lm is 0. As we can check here that 2Mn plus 3NL, that's 2Mn plus 3NL minus 5Lm is 0. And so this time I want to eliminate M. So let me club this M together. So I can club these two. I can write M times 2N minus 5L plus 3NL is 0. So negative of L plus N times 2N minus 5L plus 3NL is 0. That is negative of, and this is minus 5L squared minus 5Ln and 2Ln. So I can get minus 3Ln and then plus 2N squared plus 3NL equals 0. I can get 5L squared and 3Ln and 3Ln, so I can get 6Ln, and then negative of 2N squared equal to 0. As usual, again divide by N squared and get L over N whole square plus 6 times L over N minus 2 is 0. And product of L1 by N1, L2 by N2, product of these two roots, that is C over A, that is minus 2 over 5. So that's number 2. If I compare 1 and 2, 1 was here. So let me write here only L1, L2 upon. So we got L1, L2 upon M1, M2. That time we got as 2 over 3. So that's 2 over 3. If you combine this and this, we'll get L1, L2 over 2 is M1, M2 over 3 is N1, N2 over negative of 5. And that I can take as K. Then L1, L2 plus M1, M2 plus N1, N2. That will be 2K plus 3K minus 5K. That equals 0. And so it happens that these lines, we have got that the lines are perpendicular. So the angle between the lines is 90 degree. That's what we get in this case. Let's generalize this. So let's generalize this, because sometimes when you generalize, then you can appreciate the problem much better. First of all, there are symbols. So symbols help you to understand things better. If there are numbers, then numbers don't tell you some story. And then it is easy to lose them. It is easy to make a mistake. And moreover, numbers mask the identity. So let me write a problem which generalizes this. It says that prove that the lines whose direction cosines are given by AL plus Bm plus Cn is 0, and Mn plus Nl plus Lm equal to 0. So there are two lines whose DCs are given by Al plus Bm plus Cn equals 0 and Mn plus Nl plus Lm equal to 0. And you want to prove that the lines are perpendicular and parallel. So perpendicular if the condition becomes AB plus BC plus CA equals 0, and perpendicular if it is A squared plus B squared plus C squared, other parallel, is twice AB plus BC plus CA. So these two lines are perpendicular if first condition holds, that is AB plus BC plus CA is 0, and these lines are parallel if the second condition holds, that is A squared plus B squared plus C squared is twice AB plus BC plus CA. Notice the last example in which we have the data as some kind of 2L plus. So let me write it, and it was L plus M plus N equal to 0 and some 2Mn. Obviously, they are numbers, so this is much better to work. That's why we are working here. Now, if you do this one, then method remains same. I will eliminate one of them. So let me eliminate L. Let me eliminate one of them, say L. So I can write from first one that L equal to negative of Bm plus Cn over A if A is not 0. If A is 0, of course, we have got different things. So this is A. And then you can get here that the moment you write A, you can use this equation Mn plus, so I'll say eliminate L. So my solution will start by saying that eliminate or get rid of L. We don't want L. L is minus Bm plus Cn over A, and here Mn plus Nl plus Lm is 0. So I can take L common. I can write Mn plus L times M plus N equal to 0. That will give you Mn minus Bm plus Cn upon A n times M plus N equals 0. And so I can write this as Amn minus, I can multiply, this is Bm squared, and Bmn plus Cmn, that's B plus M times B plus C times Mn. So that's B plus C. So B plus C times Mn. N plus Cn squared is 0. I can change the sign to positive, and I can write Bm squared plus B plus C minus A times Mn plus Cn squared is 0. Now, if I take again divide by n squared, I'll get B as before, Bm over n whole squared plus B plus C minus A times m over n plus C equal to 0. And if m1 by n1 and m2 by n2 are the roots, I can write m1 by n1, same steps as before, m2 by n2 product. This product becomes C over B, which I write just recall this one, that the given condition, that was your Al plus Bm plus Cn was 0, and it was Mn plus Nl plus Lm is 0. You are getting m1 m2 over B. So this is C is coming and B is appearing. So I can write this as m1 m2. So we can write m1 m2 over 1 over B. So like this one, and n1 n2 over 1 over C, so that m matches with this B, C matches with 1 over n, meaning that by symmetry, had I eliminated something else, so suppose I get relation between L1, L2 and M1, M2. So L1, L2, M1, M2, I would have got L1, L2 over 1 over A and M1, M2 over 1 over B. So this is, you are getting similarly, that's the power of math, that you don't do the work again, the hard work. So you have done the work, just enjoy the fruits now. So these two together will give you L1, L2 over 1 over A, M1, M2 over 1 over B, and N1, N2 over 1 over C. let's call it K. And so sigma L1 L2 is K times 1 over A, 1 over B, 1 over C. If you want lines to be perpendicular, then you want this to be 0, or conversely, if this is 0, then lines are perpendicular. So that condition is 1 over A plus 1 over B plus 1 over C is 0, which simplifies after taking LCM as AB plus BC plus CA equals 0. So that's proved the first part. For the second part, that lines are parallel. First, for the second part that lines are parallel, it is much simple calculation. So let's go to this one again. If lines are parallel, then m1 by n1, m2 by n2, they should be equal. Means the roots of this equation should be coincident. So I write b times m square, or b times m by n whole square. So writing b times m by whole square plus b plus c minus a times m by n plus c equal to 0. So you want to say that this equation has got coincident root, which means that discriminant equals 0. That is b plus c minus a whole square is 4 times bc. That makes sense. So I can expand it like b plus c whole square minus 2a times b plus c plus a squared is 4bc, and b plus c squared is b squared plus c squared plus 2bc minus 2ab minus 2ac plus a squared is 4bc. And so I can write a squared plus b squared plus c squared is twice ab goes that side. So twice ab plus bc and plus ca, because 4bc minus 2bc also becomes 2bc. And so we are getting this result. So we are saying that they are parallel if this holds. Now you see that advantage of this method over the earlier method, because in earlier method there were numbers. So numbers where we did not know how 1 and 2 became 3 or what happened in between. But this is more informative. So you are working with symbols, and then advantage is that what generally paper setters do, that they set some good values there that give some answer. So it's good to do such kind of problems, which tells you that you can follow some symmetry. And notice how cleverly we did not have to do the same quadratic thing twice. We just had to do it once as compared to the previous solution, and we got it quite nicely and more satisfying solution. Okay, so now let me move to some concept about that what is the most important thing in planes, and some problems we can take up on planes also, because we have to cover the whole stuff like 3D geometry in 3 days, 3 sessions, and so we need to cover all varieties. Now planes. So the most important part of plane is this, that you have ax plus by plus cg plus d equal to 0. This represents a plane. Of course, for ABC, D are constants or parameter. And more importantly, the numbers ABC, these numbers, they are the normal to the plane. They are the normal to the plane. Means to determine not the plane, first find its normal. If you can find the drs of its normal, then plane is immediately coming. Suppose normal of the plane is 2, 3, and 11, normal to the plane. So suppose you know normal to the plane is 2, 3, and 11. Then you can quickly write the equation as 2x plus 3y plus 11g is k. And k gets determined if I give you some more condition, like say the plane passing through some point or plane doing some other job, then k will get determined. So the most important portion in plane, or the striking feature of this equation, is that numbers a, b, and c, they hold the key to the plane. So the numbers a, b, c are the direction ratios of the normal to the plane. And so once you find them, then you have to find just some other condition to get the plane. This I will use very much. And other will be taking the family of the 2D, you have read 2D family of lines. It will correspond to 3D situation is family of planes. Family of planes. So here, if you have got plane pi1 is 0 and pi2 is 0, then pi1 plus lambda pi2 equal to 0 gives the equation of plane passing through intersection of the two given planes. The way L1 plus lambda L2 equal to 0 gives the equation of lines in 2D, equation of line passing through intersection of 2 points, 2 lines, means this one, L1, L2, and all these lines. Here, plane, it means that you have got one plane as this one, and say other plane is this way. This is line of intersection, call it L. So this is pi1 is 0, this is pi2 is 0. All such plane which contains this line, like this plane, or say this plane, or say, for other example, let's say this plane. So all such planes which passes through the line of intersection of given two planes, or say other way, in other ways, that contains the line of intersection of two given planes, is given quite easily by pi1 plus lambda pi2 equals 0. Try to make effective use of this in many problems. It will be really, really interesting. So suppose I said a problem that find the plane. So I want to find the plane through the line of intersection of the plane x plus 2y plus 3g minus 4 is 0, and say 2x plus y minus z equal to 5 is 0, and perpendicular to the plane 5x plus 3y plus 6g plus 18 equal to 0. Means what you are asking is that find equation of plane which passes through the line of intersection of these two planes, and it is also perpendicular to the different plane. Means you want a plane, two planes are given, this one, two planes are given. You want equation of a plane that, say, passes through these two planes, means that is like this kind of thing, that some plane is there, some plane. So let me write a different color. So this is, say this plane is there, this plane. So two planes are given, pi1, pi2. You want that there is a plane, this kind of thing, and this plane is perpendicular to the other plane. Means there is some plane, there may be some plane like this. So let me use a different color again. So there may be some plane like this which is perpendicular to this plane. So it means there is one plane here and it is perpendicular to some other plane. So this kind of thing that we want, this is perpendicular to the plane. Of course, they all are not on the same board, so you have to visualize. So first step would be that I write that, okay, this is equation of plane pi1, this is pi2. So first step is pi1 plus lambda pi2. Means I say equation of any plane that contains this line of intersection, or that passes through this intersection of two planes. It's a line always. So that plane is given by, that plane I can given as pi1 plus k pi2. So I can give that plane as x plus 2y plus 3z minus 4 plus k times 2x plus y minus g plus 5 equal to 0. If that is the case, I can write 1 plus 2kx, simplify. So it's 1 plus 2k. So this is my plane that I want. That is 1 plus 2k times x. And similarly, I get 2 plus k times y plus 3 minus k times g, and plus minus 4 plus 5k equals 0. This is my plane. This is my pi, which was obtained by pi1 plus k pi2. So those two planes have served us. They have served their purpose. They are gone now. So this is my new plane, which indeed passes through the intersection of these two planes, means that contains the line of intersection. Now one more thing is given, that this plane is parallel to some other plane. So this plane is parallel to some other plane. So if two planes are parallel, it is going to be perpendicular. So it's to be perpendicular. It means that if I draw the normal on it, normal on this and normal on this, then the normals also must be perpendicular. So now the given plane, this plane is perpendicular to the plane 5x plus 3y plus 6g plus 8 equal to 0. So this pi and this pi prime are perpendicular. This pi has got direction ratios of its normal as 1 plus 2k, 2 plus k. So it have got 1 plus 2k, 2 plus k, and 3 minus k. This does not matter. Normal. And this normal is 5, 3, and 6. So if planes are perpendicular, then their normals n1 and n2, that also perpendicular. So angle between n1 and n2, this angles is 90 degree. And so we get the dot product is 0. So 5 times 1 plus 2k plus 3 times 2 plus k plus 6 times 3 minus k equals 0. I can calculate the term 5 plus 10k plus 6 plus 3k plus 18 minus 6k is 0. So all I will get by this kind of thing, that you will get 18 and 6 and 5. So we'll get 29, and plus this is k. So you're getting 13 minus 7. So 29 plus 7k is 0. You will get k equal to negative 29 over 7. So it means we got a value for k, for which indeed this line, this plane, the required plane, contains the intersection of these two lines, which is passes through these two planes, and is also perpendicular to the other plane 5x plus 3y plus 6g plus 8 equal to 0. Now our time is just to get the answer. So this is my plane. I already got the value of k. So I can write 1 plus 2k. So 1 minus 2 times 29 by 7 x plus 2 minus 29 over 7 y plus 3 plus 29 over 7, that is g, and then plus minus 4 minus k into 29 over 7 equal to 0. So this will be your 7 minus 58. So you will get minus 51 over 7x, then minus 15 over 7y, 14, and then 21. So this is 50 over 7g, and this is minus 28 and minus 20 into 1, 5. And so they together, they will give you negative of 173 over 7 is 0. I can change all the signs, and so equation will be 51x plus 51y and minus 50g and plus 173 equal to 0. So ultimately you have found the equation of the plane, which does two things. First, this plane passes through the intersection of two given planes, and it is perpendicular to a third given plane. So remember what we were given. Just let me go back and tell you that given was this. So this was given that you have to find a plane that passes through the intersection of these two planes. So of course we got this kind of thing. So we wrote pi1 plus lambda pi2, and then we wanted that this plane, the new plane, should be perpendicular to this plane, and so normal must be perpendicular. So once I wrote these two conditions and I wrote what k must be, and then we have found the plane, that okay, this plane must be like this. Okay, so that's all for today. Let me stop sharing. Okay, then let's see each other tomorrow.